Welcome, one and all, to my awesome gummy bear experiment with sweet gummy bears and hypertonic and hypotonic solutions. So let's talk a little bit about what we're doing. Let's get to the experiment, and then we'll show some results and some fun little stuff. All right, so first off, as you can see in front of me, I have 4 gummy bears. Okay, and then off to the sides, I have a green cup, which has salt water in it, and I have a red cup or purple cup, maybe I'll wink later, that has normal water in it. So what we're going to find out today is what happens when we put a gummy bear with a gelatinous body inside a cup of normal water, and then we put a gummy bear inside a cup of salt water, and then we'll have a gummy bear as a control that doesn't go in any water. Now I know what you're thinking, Ben, you have 4 gummy bears in front of you, and that's because the 4th one is for me to eat. Suck it, you're not here with me. All right, so we'll use this gummy bear as our control. He's clear, he looks cool. The red one will go in the water. This one will go in the salt water. And then with the magic of editing, poof, we are now way in the future. And we have our salt bear, and we have our water bear. And so that we can better see them against these backdrops, I had made fun little plates for us. Maybe I need more space. We're gonna make some more space right quick. All right, well, we'll make it work. So control gummy bear. He is that big, and he is pliable, he's squishy, he does his thing. Next up, we've got Salt Bear. Let's fish old Salt Bear. He's been sitting here for 10 hours. Oh, he's kind of pliable. Surprisingly, he's still pliable, he's still squishy. He's taking on some brackish color, but that's probably because I picked a clear one. But, you know, he doesn't look that bad. Control bear versus him. He's definitely lost a little bit of definition. Doesn't look that bad, though. I thought he would have been like, you'll see that. That was my hypothesis later. Then finally, we have water bear. Oh, he does not feel good. Oh, gosh. He might collapse. Water bear. So I had some funness last night and this morning. So he's huge. It's being water all over my table. I had some funness last night. I put all these guys in before I went to bed to give them some good time. And when I woke up this morning and came downstairs, my water cup was completely empty. I was like, what happened here? I think my cat came and drank all the water, but not before Water Bear got freaking swole as a gym rat. So as we can see from our 3 bears, we 3 bears, that's a cartoon my kids watch sometimes. Control, salt, water. The water bear obviously swole up, got all swole, and he is very juicy. We're not going to eat that bear. Let's talk a little bit about what happened and why it happened. Oops, that's not what I wanted. And we're going to call it osmosis. So osmosis is the process where you have 2 of the same solvents. One is a solution. I'm sure you can see there's green dots in there. So it's got a solvent in the solute. It is a solution. And then we have half of it is just a solvent. The same solvent. Well, what happens is this side with the solution, because I could speak well now, it is hypertonic, meaning it's got more particles in it than the other side. And what this solution wants to do is it wants to become isotonic. So it wants to have balance on both sides. So what will happen is particles of the solvent on this side without any solutes will cross a membrane bloop, to get over here in the idea of balancing the two out. And so that's kind of what's happening with our gummy bears. Let's talk about that a little bit. First up, normal bear. These are control bear. Not much to say here. Just a bear. I can't tell if all this stuff is going to show up backwards in the video. If it is, special treat. If not, good on me, because I'm not going to write things backwards. Normal bear, no water, no solution to come in and out of him. Life is good, life is kosher. Next up, water bear. As we saw, he was waterlogged. And what was happening is that inside a water bear, the skin of the bear acted as that membrane that we talked about. And he was hypertonic as compared to the water that he was sitting in. And so he started to absorb the water to try to make an equilibrium, try to turn himself isotonic. These little dots are all the water molecules, and you can see they get inside of him. Those are the... Opa! Hope you don't vomit easily. Those are the molecules inside of all the squigglies. And these are the molecules trying to go to get inside of him. It's collapsing. Water bear. So that's what happens with water bear. He took on a lot of water to try to become isotonic. And then we have salt bear. You might find this jarring. I had to do a little edit. Anyways, salt bear. What happens with salt bear is that the water is already full of particles. And so it more matches that of the bear. So the bear is not uptaking water to try to find equilibrium. I thought salt bear would shrink up a bit. I thought whatever moisture was in the bear would exit to try to become, try to help the solution become more isotonic. But it wasn't the case. The bear actually looks like he soaked up a little bit of water. A little bit of salt bear water. But he, for the most part, looks a lot like the control bear. Just wet. All right, thank you guys. I hope this was informational. I hope this is good grade material. And thank you.